Okay, so here we go. So right now, from this moment on, as Shania Twain would say, or anybody else who takes those words, from that moment on, we are working on something called stoichiometry. Stoichiometry is going to put all the things we work together into one little bow here. So it's got a little funny name, stoichiometry. But what it is an application of the conservation of mass. What is conservation of mass? And because matter is neither created nor destroyed, what can I do with this reaction to figure out how much I need? I can, because the same number and the same type of atoms have to be on both sides, I can balance it. And balancing is powerful. Remember last week we saw that the hydrogen balloon that gave up the largest boom is when we got a 2-to-1 ratio. The 1-to-1 or pure hydrogen didn't give us a loud boom because we didn't have all the hydrogen reacting. How much of each element we need to react is inherently being told to us by the numbers that we need to balance. Let's balance this reaction. Okay? Because if you don't balance these reactions, you can't do any of these types of problems. Now, I have one carbon. I'm good. I have 4 H's. I've got 2 H's. What do I have to do here? I have 4 H's on the reactant side, right? So I have to have the same number on the product side. So I need 4. So what am I going to do? Put a 2 in front of the H2O. This gives me 4 H's. Now, notice I have 2 oxygens here, and now I have how many oxygens here in the water with the 2 in front? 2. So I have a total of how many oxygens?
2.
I have 2 on this side.
4.
Yeah, 4 altogether. Correct. How do I get 4 oxygens over here? How do I fix that? 1 carbon, 1 carbon. 4 H's. We put a 2 in front to give me 4 H's on this side. I have 2 oxygens and 2 oxygens here. To get 4 oxygens on this side, what do I put in front? A 2. And now I'm balanced. And now it tells me something very powerful. And this is what stoichiometry is about. Using something called the mole ratios. Now here's a question that I'm going to hold you accountable. What is the ratio of methane to oxygen? How much methane completely reacts with how much oxygen? What's the ratio? 1 to 2. That is a Regents question. What is the ratio between the oxygen needed to react with methane and H2O produced? 1 to 1. 2 to 2 is 1 to 1. Now why are those important? Because as a chemist now, after I have balanced and looked at the law of conservation of mass, as a good cake maker, I can make good cake. I need twice the number of O2s for a CH4 with no leftover. But it can tell me something else. Watch this. If I have a 1 to 2 ratio between CH4 and water, so 1 to 2, that's not a heavy. That does not mean that the water is twice as heavy. This is a number ratio. That's why we do moles. Mole concept. Chemistry is about how many particles. One of these molecules, if I have enough oxygen, and now we know it's twice as much, we produce twice the number of particles. So one CH4 molecule will produce 2 water molecules. That's what it means. And it's powerful because I know that one of these will produce 2 of these molecules, right? We'll just draw it out. Here comes another one of these, 2 waters, and then this makes how many CO2s? One of these? Okay. So one of these particles will make 2 of these particles. Because I know that from balancing, what if I have 5 moles of methane? How many moles of water will I produce, assuming I have enough oxygen? 10 to 1 to 2 ratio. Once I balance, what we're going to do for the first time is we're going to convert from information from one element to another. So watch this question number 1. And I'm going to do it for you 2 ways, okay? For my people who are going to go on to AP Chem with me, you better do it the first way here. For those that are not going to continue just surviving to get through this, you're going to do it the second way. Now watch. Okay? How many moles of carbon dioxide are formed when 40 moles. The first thing you do with a math question, party people, is put the number given to you. 40 moles of oxygen. And it's so vital to put down not only the number and the unit that I always harp on, or sometimes piccolo on, okay? And me playing a piccolo might be funny, okay? All right, now, 40 moles, I'm now going to write what, 40 moles of what, because I'm going to take you from oxygen to CO2. This is what stoichiometry is. We're going to use these ratios to go from one chemical to another, knowing it's a 1 to 2 to 1 to 2 ratio. So watch. How many moles of carbon dioxide are formed when 40 moles of oxygen is consumed? So, my friends in chemistry, I'm going to times it by, like I've been doing all year, a converting factor. But for the first time, in the converting factor, I'm putting O2. Because I'm getting rid of O2. They're starting me with oxygen information, and they're asking for another chemical. I'm starting with oxygen information, and I want to get CO2. Now, some of you guys can do this in your head. It's a 2-to-1 ratio, but I want you to write it out because it would always be clear. So I'm going to get rid of O2 to get what? Can everyone see they're asking about CO2, but they're giving you O2 information? Yeah. So I got to get rid of O2. So O2 goes in the bottom. And then we want what? We want CO2. Now what numbers do I put? There are 1 CO2 for how many O2s? 2. And for the first time, party people, we're canceling out chemicals because it's a 1 to 2 ratio. If I have 40 moles of O2, shouldn't I have half as much CO2? And the answer is yes. Okay? So this, of course, goes bye-bye. 40 times 1, I can do that one. 40 divided by 2 is 20. And this is important. 20 what? 20 moles of CO2. Notice we didn't get rid of mole. We're not going from moles to grams, grams to mole. We're going from one compound to another. That's what stoichiometry is. Think with me for a second. I'm building a factory. Okay, or I'm just a chemist who wants to make something. All right? Knowing my ratios, I can figure out exactly how much I'm going to make. If I was a cake maker, okay, and I want to make 1 cake, I take my recipe, and 1 cup of flour, 2 cups of sugar, whatever it might be, gives me 1 cake. If I want to make 2 cakes, what do I do with my recipe? Double it. And by doubling, do I change my ratios? No. No, that's the key here. By balancing, we get the ratios we need for the good reaction, the good cake. All we're doing now is figuring out, hey, if I want to make 13 cakes, how much sugar do I need if I know it's a 1 to 2 ratio? If I want to make half a cake, I would do what with these ratios? So I'm always dealing with these ratios. Yes?
Why would you cancel out the O2 if you need the O2 to make CO2?
Okay. I'm not canceling out the reaction. I'm canceling out the information. If I know that I need 2 cups of sugar to 1 cup of flour, okay, to make 1 cake, 2-to-1 ratio, I'm not canceling out that I don't need it. I'm just canceling out the information. I'm starting, knowing that I'm starting with 2 cups of flour. How many cakes will I make? Okay, so it's just telling me that I'm not canceling out the reaction, I'm just canceling out the information. So knowing you have this much flour, how many cakes will I make? For every cake, you need 2 cups of something. So if I have 10 cups, I'd make 5 cakes because it's a 2-to-1 ratio. I'm just taking this information from one and converting it to another. Now, for those who don't like that, here's another way you can do it. Watch. Okay? Now, for my people who are going to go on, you can understand this, but watch. Okay, so here's the question again. Now, what's the question say? How many moles of carbon dioxide? Carbon dioxide is my unknown. Write it above. Are formed with 40 moles of oxygen. 40 moles of oxygen. Oxygen's over here. Notice it's diatomic. So what I just did is, what they were asking for is my unknown, my X. Now I have to use Y, P, and other elements, letters, but hey, who cares? Okay, 40 moles of oxygen. given here. I'm going to make a proportion. Watch. The coefficients become the proportion. So this 2 is over 2. This is over 1. What do I have? 40 over 2 equals x over 1. Solve for x, and you'll get 20. It's not my favorite way of doing business, okay? But you get the problem right. However, this only works if, in fact, it's a mole-to-mole problem. This is a how many ratio. So this better be a how many ratio. Okay? Let's go flip this on to the yes?
Is the first way that you showed us, like, would you say is, like, easier than the second way?
I prefer this way because you're using units. For those that need to survive to get it right, here's another way. I prefer you try this way first, but I don't care. Get it right. But in multiple step problems I'm going to show you, this is going to be more helpful. However, to get the mole-to-mole right, here it is. Number 2, how we set it up. How many moles of methane are needed to be 200 moles of water? What do I write down first? 200. What's given to me? 200 moles of water. What are they asking for? They're asking for methane. They're looking for moles of methane. So I'm getting rid of the information about water to get methane. And this is a real life scenario, guys. Think with me for a second. I want to make a certain number of cakes. Do we ever work backwards? I'm a cake maker. I want to make a certain number of cakes. Can I figure out how much ingredients I need? I know the ingredients per one cake. So if I make 20 cakes, I can work backwards. So information about the product, give me how much of the stuff you need to make it. That's power. Okay, I'm getting rid of what? Moles? They gave me information about water. What am I getting rid of? I'm getting rid of water. To get what? CH4. What's the ratio? Look at the reaction. Use the mole ratio. We have how many CH4s? No number in front is what? 1. How many numbers is the H2O? 2. Look what cancels. And you're dividing by 2. I know that some of you guys can see that right away. And your answer is 100 moles of methane. Now, if you did it the other way, you put your x over 1. You put your 200 over 2. Solve for x. These are not hard problems. But if you do not recognize what you have to do with these problems, they become hard. The box question that we learned about empirical to molecular is not a hard problem, but people are not recognizing them. That's why you have to understand what you're doing. We're using these ratios of how many to figure out how much product I should make given a certain amount of what I'm starting with, or how much reactant I need to produce a certain amount, or how much of each other I need. Hey, if I only have a cup and a half of flour, and I know it's a 2-to-1 ratio, how much sugar should I be adding to make a smaller cake? Okay, let's go on to the back page. How much time don't I have left? 3 minutes, good. All right, let's go to the back page. Let's balance this guy. Or gal, I don't know why I guess I'm being sexist. Okay, 1 magnesium, 1 magnesium. Oh, 2 chlorines. So what do I put? The 2 in front of what? Right. And then that gives me 2 H's, 2 H's. So we're balanced. And here are my ratios. Okay, now listen to this question. This question's a little bit different. How many grams of magnesium, how much of this in mass, do I need to produce this much cake, H2 in this case? Now, there's a problem here. Someone tell me the problem. This is different than the first one we just did. What's the problem here? Is this a ratio of how heavy or how many? How many? What kind of number is grams? a how heavy number. I can't use grams into a grams and a how many are two different things, aren't they? So what's my first step in this problem? Convert to moles. I've got to be in a how many number to use this. So how many grams of magnesium are needed? If I have 100 grams of hydrogen, my first step, party people, I take 100 grams of hydrogen. I'm going to convert to moles. Where do grams go? On the bottom. And I want a mole, or I want equivalent of a mole. How many grams equals 1 mole of H2? Well, each H has an atomic mass of 1, so 1 plus 1 is 2. Okay, cross them out. What does that give me? That gives me how many moles? 100 times 1 divided by 2? 50 moles of what? Of H2. We just converted to moles. Now I'm in a how many number? This was heavy. Now I can put this in my X and rock and roll. So my first step, or my second step here is to take this number and convert it by the mole ratios. I want to get rid of H, right? They're giving me information about H to get what? Magnesium. So I'm going to get rid of H2. I want magnesium. What's the ratios, guys? For every how many magnesiums? It's a 1, and there's a 1. It's a 1 to 1. I know it seems silly, but we're going to keep ourselves organized and cancel. So what does this give me? 50 moles of magnesium. H2 is gone. Now what do they ask for? What do they ask for? How many grams of magnesium? Is this grams of magnesium? No. So my last step is I've got to convert my 50 moles of what? Of magnesium and convert that to grams. 1 mole goes in the bottom this time. Why? Because you want to cancel it. For every 1 mole is how many grams of magnesium? Go to the periodic table. The atomic mass of magnesium is 24. Okay, what am I left with? 50 times 24, what's that number? 1,200. And what did I just solve for? 1,200 grams of magnesium. Why were there 3 steps in this problem?
Because you need to convert.
Because you gave me grams. I had to get into a number to use this ratio. I got moles, moles out, then convert to grams. I would like you to do number 2 of this problem, of this side, and number 3 of the first side. Just 2 problems for work, go home. Have an okay weekend.